Hey, 6th grade. Today's video has 3 learning goals, and we're going to be learning about understanding variables. So anywho, you have 3 learning goals, and you're going to have several vocabulary words, so make sure you have your binders and your pencils ready. So we're going to start with our learning goals, and the first one is, I will define variables. Your second one is, I will write and evaluate algebraic expressions. You're going to be hearing those terms a lot, algebraic expressions, over and over. And number 3, I will write expressions. So make sure you hit pause so that you can take a couple minutes to get all of that written in your notes. The 3 learning goals: I will define variables, I will write and evaluate algebraic expressions, and I will write expressions. Okay, so now it's time for the vocabulary words for this lesson. And guys, I know that these words are all going to be kind of goofy, but don't worry because they will make more sense as we continue through the lesson and even the next couple videos after that. This will all come together, I promise. So your first vocabulary word is variable. And a variable is a letter or symbol used to represent unknown quantities. Don't worry, we'll figure out what that means here soon. Your next vocabulary word, and this was part of your learning goals, your next vocabulary word is algebraic expression. I mean, what in the world is that? And an algebraic expression is a mathematical phrase that is involving at least one variable, whatever that is, as well as numbers and operations. And you guys already know what numbers are. You already know what operations are. So now we just have to figure out what to do with this variable part of things. Your next vocabulary word is equation, and that is a mathematical sentence that contains an equal sign. I think you guys can figure out that one. And because a lot of our math sentences, our equations, have equal signs at the end because you have to figure out the answer. And then your last one is inverse operations. All right, inverse operations are mathematical operations used to solve equations. So, addition into subtraction, those are opposites of each other, but those are inverse operations, basically because they're opposites. And we use them to solve the different equations we have. Multiplication has an opposite of division, and those are our inverse operations. Okay, so let's give some of this a try, and here in the next few minutes, a lot of these vocabulary words will start to make a lot more sense. So we are going to go with the real-life story of how we need to figure out how much it's going to cost to ship small flat rate boxes. And for this particular bunch of problems, it's going to cost $4.95 per box to ship these boxes. So what would be the cost to ship 6 of them? And we will use a numeric expression to calculate the cost. So you'd have $4.95 times 6 to calculate the shipping of 6 boxes. And the total for that is $29.70. So how much do you think it's going to cost to ship 12 boxes? Well, we do the same thing. $4 times $4.95 times 12 equals $59.40. And make sure you remember to put in that dollar sign. How much is it going to cost if we want to ship 17 of those boxes. Somebody's going crazy sending boxes. So we multiply $4.95 times 17, and we wind up with a total of $84.15. So basically what this is showing us is that we can determine the cost of shipping our boxes just by multiplying the number of boxes shipped times $4.95. So when we look at these problems, what quantities change? Does the cost change? The number of boxes shipped? Or the total shipping cost? Which quantities change? And if you said the number of boxes and the shipping costs are the two quantities that change, then you are correct. But then there's a quantity that remained the same. And the cost to ship the small boxes, that $4.95, remained the same throughout all of our numerical expressions. So in these questions, there was one quantity that changed or varied. This is where that variables thing is getting ready to come into play. When we use letters or symbols to represent quantities that change or vary, they are called variables. So we can write an algebraic expression to represent and solve these mathematical equations. So when we write an algebraic expression, and there's one of your vocabulary words, you are going to include at least one variable as well as numbers and symbols. And we're going to see just what that means here in a second. So in the problems that we just solved, the number of boxes changed every single time. So after I get all of this cleaned up, we're going to write a little something out. So we had, wait, I don't want it there. We had $4.95 each time, right? And there's another $4.95. And another $4.95. The flat rate stayed the same. The cost of the number of boxes that we shipped, though, that is the part, that's the number that changed, the quantity that changed. So number of boxes changed. Or varied. So let's try to use some of this information that we have here in an algebraic expression. You guys are finally going to get to find out what the heck an algebraic expression really is. So let's clean up our space here a bit. Make sure you're getting all of this in your notes. So we're going to, there's two things you have to do when you solve an algebraic expression. The first thing you have to do is select a variable. You have to decide how you're going to label the changing quantity. So for this particular bunch of boxes that we're shipping everywhere, we are going to use the letter N. And N is just going to represent number of boxes okay? And we're going to assign this n to the changing quantity in our algebraic expressions. The second thing you have to do is replace the given value of the number of small boxes with this variable, with our n. So your numerical expression, your algebraic expression, it can be written like this: $4.95 times n, or you can write it as $4.95 times n just without the parentheses. So in your binder, I want you to do a couple of things. Let me get this out of our way. And hopefully you got that in your binders. If not, you need to rewind and pause and make sure you get it. All right, so in your binder, I'm going to give you 3 different problems to do, And I want you to find the shipping cost for the 3 quantities, but you're going to use the algebraic expression $4.95 times n. So on the first one, you're going to have 20 small boxes. So remember, you have to use $4.95 times n. For number 2, you're going to find how much it costs to ship 100 of these small boxes. Still using the same expression, $4.95 times n. And then the third, you're going to find out how much it costs to ship 252 small boxes. And you're still going to use $4.95 times n. So make sure you get all of this in your notes, and I'll see y'all in class.